Today's lesson is Mathematics 1581, that is Mathematics 1 Engineering. The topic for today, we are going to look at modulus. The modulus is under the topic called complex numbers. Let us start. We have modulus and augment. Augment will be under lesson 1.2 of complex numbers. So in this lesson video, we are going to focus only on modulus. Now let's say we have this complex number z, which has a plus bi. Now how do we find the modulus of this complex number? Suppose we have this Cartesian plane. We know that from algebra we normally denote this as y and x axis. In complex numbers we have m and re. And then this is our complex number z. Then complex number z, it is composed by two sides which they form a 90 degrees here. Now this side will be a, then b is actually this side. So if we can check this equation, compare it to the algebraic, or we try to write this in a coordinate form, we know that coordinate form is x, y. For complex numbers is a, b. I hope you can see. Now how do you find modulus of this complex number? We have many ways to actually indicate or denote modulus of a complex number. This is the equation that we are going to use. Yes, it is familiar to the theorem of Pythagoras, or we can say it is the theorem of Pythagoras. Sometimes you will see something like this. It's the same as the modulus, or the modulus of a plus bi is equals to square root of a squared plus b squared. Or we can use mod of z is equals to square root of a squared plus b squared. Basically, we simply take the square of both of the sides raised to the power 2, and then we are going to find the modulus. Some say modulus is actually equals to the side which is the hypotenuse side. Well, it is correct, because using this equation we are trying to calculate the longest side. So let us look at several examples on how to find the modulus of a complex number. Look at the application and then we'll be good to go. Find the modulus of 4 plus 3i. So we can see that we have, this is a, this is b, so it means we have 4, 3. Then 4 is 4 units to the right, so we can take this as 4 units to the right. And then 3, it's actually positive 3, it's 3 units to the up direction, which is a positive direction. And then our modulus will be here. So this will be z, this will be 3, then this will be 4. So to find the modulus, we are going to use this equation, squared plus b squared. Then this will be z, going to have 3 squared plus 4 squared. We are going to get, this is 25. 25 square root of 25 will give us 5. So the modulus of this complex number is 5. Let us look at more examples. Our next example is z is equals to 3 minus 2i. So you can see we have 3 units to the right, then we have 2 units downwards. Since it's negative, then our modulus will be here. This we have 3, we can see this is negative 2. So we take A is 3 squared plus, doesn't matter whether you include this negative or you exclude it, but just make sure you put the brackets when you include the negative. I always put bracket whether it's positive values or negative values. This will give us square root of 13. So this is the modulus. Our last example is a bit different from the previous ones. It says W is equals to minus 9 plus 3i all over 1 minus 2i. Now before we start, I want us to go through some basics of complex numbers. You should know that I squared is the same as negative 1. That one you should understand. It will actually assist us. So how do we solve this? We are going to treat this as we are rationalizing this expression, meaning that we are going to multiply by 1, but we express 1 in terms of the denominator, but we change the signs. Then let us introduce the braces. Then from here it's negative 9 multiplied by 1. We are going to have negative 9 multiplied by 2i. We have negative 18i. Positive 3i multiplied by 1 is positive 3i. And then positive 3i multiplied by 2i. So let's say 3 multiplied by 2, we have 6. I multiplied by I, it will be negative 1. Let me actually take it step by step. I have I squared here. All over 1 and 1, we have 1. 1 and positive 2i, we have 2i. Negative 2i and 1, negative 2i. Negative 2i and positive 2i, we have negative 4i squared. Remember we said I squared is equals to negative 1. So let us go ahead and do this. It's actually negative 18. But let us simplify this. Negative 18 plus 3i is negative 15i, plus we have 6, then we have negative 1 here. 1 plus this and this will remove each other, and then we have, let's actually do this. We are left with negative 4, negative 1, since we said I squared is negative 1. Then from here, let us simplify negative 9 minus 15i squared minus 6 all over 1. Negative and negative, it will give us positive 4. So negative 6 minus 9 is negative 15 minus 15i all over 5. Then from here, we take each and every term, separate by taking each and every term with that over 5. So negative 15 divided by 5 is negative 3. Negative 15i divided by 5 is negative 3i. So this is our complex number. Then we can apply the modulus equation, which will be W is equals to square root of a squared plus b squared. Okay, see our x is negative 3 squared plus negative 3 squared. We find that our modulus is 3 square root of 2. So this is our final answer. I hope this was helpful. Stay tuned for lesson 102, where we'll be looking at modulus and augment of a complex number. This is Modulus SJ. Thank you very much.